Quadratic equations with perfect squares. The good news is we're starting this chapter with stuff that you guys kind of already know how to do. I'm going to show you a few examples. We are going to need to do a little bit of factoring, but I'm going to start out with some where you already know what to do because this connects to our last chapter. Quadratic equations. Quadratic, if you remember, we covered this a while back when we were talking about linear equations. Linear equations are the ones that make a straight line when you graph it, and they don't have any exponents. And on a previous test, and I can't think what chapter it was right now, like 8 or 9, I had a bunch of questions. It was when we did those parabolas. We graphed those quadratic equations, and it was, what's quadratic? And if it has a power of 2, it's considered what we call a quadratic equation. If we were to graph this, it would have been, we're not going to do this, don't worry, but it would have been one of these parabola shapes on the graph. Okay, so just kind of to remind you of some of this vocabulary, right? We already have learned quadratic equations, and they're going to have perfect squares. So we're going to start out nice and easy. There. No, they're not going to be that easy as we go through. But that's the simplest form of what we're doing is this. Now, for this chapter, I'm really going to be asking you guys, I think I know one person for sure did this on the test yesterday, but that plus and minus symbol that I've talked about, we're going to be focusing on that a little more in this chapter. If I want to solve this, I want to undo the power of 2 to solve for m. I take the square root of both sides because that undoes the power of 2. And I want your answer not just to be 7, but to be the plus or the minus 7. If you've been doing this, you're in the habit of it already, so you're good to go. But really the idea here is we are going to be really focusing on this, and I'll show you why when we get to the factoring ones in a minute. But that it could be positive times positive or negative times negative. It doesn't mean mixing positive and negative, right? But it means positive 7 times positive 7 would be 49, and negative times negative would also be a positive 49. So I'm just going to be asking you, we'll start today, to really make sure that you have this on any of your number answers. Okay, again, still sticking with stuff we did in the last chapter there. So nothing brand new yet, but just showing you a few different types of equations. We did something like this, 5r squared equals 45, and the thing I would have said to you if this were on the test and you asked me, I would have said only the r is being squared. Okay, if there's no parentheses, it's just the r. So before I try to get the r by itself, I'm going to first undo the 5. I'm going to divide both sides by 5. R squared equals 9. And now you guys can imagine what's going to happen here. We take the square root of both sides to get r by itself. And again, instead of 3, plus or minus 3. Okay, hopefully nice and easy so far. Next one. It's going to look like it's going to be hard, but don't worry, this is not a hard one yet. X plus 6 squared equals 64. Notice here are the parentheses. It means the whole thing is squared. We could FOIL it, but we don't need to. If the entire thing is being squared, I just want to undo the power of 2. So I'm going to take the square root of both sides. Now on the left side, square root, power of 2 cancel out, leaving the x plus 6. Now, here's where this plus and minus is going to make a big difference. Square root of 64 plus or minus 8. Don't forget, we still have to simplify all those perfect squares. Now, how am I going to get the x by itself? That part's easy. Diego. I'm going to subtract 6 on both sides. Now, here's where we got to pay attention to the plus or minus. I'm going to, technically, any quadratic equation, which is what we're doing, will have 2 answers. So far, let me go back up, we've showed the 2 answers just with the plus or the minus. The 2 answers here are positive 7 and negative 7. The 2 answers here are positive 3 and negative 3. The 2 answers here, well, what if I start with positive 8? The 8 could have been positive or negative. What if I take positive 8 minus 6? What do I get?
2.
2, right? Well, what if it wasn't the positive? What if it was negative 8 minus 6? CJ?
Negative 14.
Good. First of all, right, we'd add the opposite. Here are my 2 answers, and on this one, they are not the same number. You should have 2 answers for every equation. In some cases, if it's the same number, positive 3, negative 3, you just put that plus minus in front. But if you get something like this, plus or minus 8 and minus 6, I need you to find the actual two answers. Again, the positive 8 minus 6 gives 2. What if it was negative 8? Negative 8 minus 6 makes negative 14. Here's my two answers. Every quadratic equation should have two answers. So that's where that plus and minus really becomes crucial, because you can't just say 8 is the answer. Or if you did 8 minus 6, you'd say 2, but there's two answers. I need that negative 14 also. Okay, now, I think I said we were going to factor, but I'm not going to give you too much factoring just yet. So I've just got two more examples I need to show you. 5, parentheses, x minus 4 squared equals 40. Second to last example. So again, what you want to look for is what's being squared, what's in parentheses, what's not being squared. I don't want to take the square root of the left side of both sides, because this 5 is not being squared. So I don't want to take the square root of it. Now I've created an irrational square root, the square root of 5. So instead, what I'm going to do, before I can take the square root, I need this part to be by itself. What's being squared is the parentheses. So the first thing I'm going to do is get rid of this 5. It's being multiplied, so I divide. Now I have something where the only thing happening on the left side is being raised to the power of 2. Now I can go ahead and take the square root of both sides. On the left side, again, they cancel out, leaving x minus 4. Now on the right side, 8 is not a perfect square. We need to do what we did before with it. Before I do anything with the left side, the x minus 4, I need to simplify my 8. Remember that this would be finding the perfect square factors. The square root of 4 is 2. And the other 2 stays underneath, and now again, plus or minus. Right? It could be positive 2 times positive 2 to get that 4, or negative 2 times negative 2. So again, the plus minus is always going to be on the number that's outside. Now on the left side, I still have x minus 4. When I add 4 to both sides, there's good news here. You do not need, if you have something like this, remember the square root of 2, this is what we call an irrational square root. It doesn't have a whole number perfect square option. You can leave it like this. Let me show you the standard way to write it. The standard way is to take anything loose, like this 4, and put it first. Plus or minus, and then the irrational part of the square root, the 2 root 2. If you have the 4 at the end, like I had on this previous step, that is still correct. We can add in any order. I will accept that. But I'm going to be showing you the answers like this, so just know that that's an alternative way to write it. And you can leave it like this. Do I have two answers here? Every quadratic equation has two answers. Do I have two? Okay, thumbs up. What are they? What are my two answers? Brian.
4 plus 2 times the square root of 2 and 4 minus 2 times the square root.
Perfect. You don't have to tell me exactly what that final number is, but I do have two answers. 4 plus 2 root 2 and 4 minus 2 root 2. That would give two different numbers. I don't need decimals on this lesson. Just leave it like this. Okay? And finally, last one. Hi, trinomial. You guys are going to hurt its feelings. Here's the good news, guys. Any trinomials that you get today, you will get because they fit the pattern of the square of a binomial. This is where we have a plus b or a minus b. Since we're squaring it, it would mean they're both the same, so it's not the difference of two perfect squares. Since these are all pluses, it means this is the pattern with a plus. And all I have to do is I'm going backwards. Here's the a squared, here's the b squared, here's the 2 times a times b. If y squared is the squared part, what was before it was squared? What's the a? Vincent? Y. If the 9 is squared, what was it that was squared, Kate? 3. That's all you have to do for factoring. If you get a trinomial today, it will be one of these. Because the whole point of our lesson today is to get something where we can undo that power of 2, which means it will fit one of these patterns, the square of a binomial. Now I've got it factored. Now I just take the square root of both sides, canceling out here, remembering my plus or minus in front of the 7 over here. Subtract 3 from both sides. And since these are just whole numbers, we need to get final answers. If it was positive 7 minus 3, that gives me 4. If it's negative 7 minus 3, that gives me negative 10. And I'm done. So again, any trinomials, you're going to want to follow this square of a binomial pattern. And that's it.